Okay, rock and rolling right on to 9-6, reference and special angles. So, once you have seen this video, we will have done unit circle in class. And we'll have talked a lot about reference angles and special angles. So, let's graph these four angles and see if there's any relationship that we can figure out with those. So sine of 40 degrees is going to be right about there. Yes? Okay. So the sine of 40 would be this height right here, whatever that is, height over the radius. Okay, sine of 140, well 140 would be 90 plus another 50. So it would be right about here. So what I want you to notice is that this is 40 degrees above the x-axis. So this is 180 minus 40. But it has the same height as our 40 degree angle did, right? So for our sine, it would have the same sign, both positive and same amount. Sine of 220, we would go 180 and then down another 40, so be at 220 right here. If you notice, it's actually the same distance, except now we're in a negative. So this would be a negative sign. So this would be positive sign, positive sign. This would be a negative sign, because sine is our y value, at 220, but it's at the same angle. So it's going to be the same amount, just negative instead of positive. And then sine of 320 would be 360 minus 40, which would be around right there. So 320 would be here. This also has a 40 degree difference between 320 and back at 360. So all of these have what we call a reference angle of 40 degrees, which basically means you can find the measurement from that reference angle, and then just depending on what quadrant it's in might change your cosine or sine or tangent values. So and your reference angle lies in quadrant 1. Oops, lies in, sorry about that, quadrant 1. That's where we're always going to refer back to. Okay. All right, so let's go down here and we'll figure out the reference angle. So one way you can look at this is that 150, well, that is a 30 degree angle here because it's 30 more degrees back to the x-axis. So its reference angle would be a 30 degree angle. So that would be 30 degrees. Negative 100, let's think about where that is. So negative means I'm going to go clockwise. So here would be to 90. Right about there would be 110. So if I go straight diagonally from there, and I'm going 10 short of the 90 degree angles, that would be an 80 degree reference angle. Or if you think about it this way, I'm in quadrant 3, 180 degrees around the circle is my basis for quadrant 3. It's in this area here. 180 minus 100 gives you 80 degrees. Okay, let's think about in radians now. Well, I know that 2 pi gets me all the way around the circle, right? So if I convert that to 12ths, that would be 24 pi over 12 pi. It's the same as 2 pi. And so if I want to see kind of where I'm at, that's going to give me pi over 12. But if I think about that on a circle, right, 23 pi means I've gone almost all the way around, gone to right about here. Okay, so my reference angle would be pi over 12, which is right there. Okay, all right, so let's talk about some special angles, and you're probably going to recognize these from geometry. So I want you to think about some of those special triangles you dealt with in geometry. So you had 30, 60, 90 triangles, and you had 45, 45, 90 triangles. Those are definitely going to come back into play, and they play a huge part in the unit circle. You know, we've already kind of seen that. So you will know that for sure by now, but now we're going to start really using those a lot to know our angles and know our sine, cosine, and tangent values. So let's start with a 30-degree angle. So that's right about there. Okay. And we know we have a radius of 1 in a unit circle. And we're going to drop a vertical line right down there and make a triangle out of it. So with 30, 60, 90 triangles, the rule was that the short leg is half of the hypotenuse. So in this case, that short leg is going to be half. And then the long leg is going to be our short leg times square root of 3. So this gives us square root of 3 over 2. Okay, and that's for a 30-degree angle. And we're going to use those in that chart that we're going to make a chart of all of our trig values. And I'm not sure if you'll see that before or after you do these notes, but either way, we'll be doing that in class. Okay, so let's think about what if we flip that around. Let's make this a 60-degree angle. Okay. Oh, and let's practice. So this would be pi over 6. And 60 degrees in radians is pi over 3. That helps us when we're filling in our unit circle. Okay. And again, we know this radius is 1. It's 1 no matter what. The short side is half of the hypotenuse, and the long leg is that short leg times square root of 3. Okay. So for example, if I was asking you the cosine of 60, that would mean I would have adjacent over the hypotenuse, which is 1/2 over 1. But also I know that my cosine is the length of my triangle on this x-axis, which is 1/2. If I were to look at sine, that's opposite over hypotenuse, which is square root of 3 over 2, over 1, which is just square root of 3 over 2. But this is also my y value. Remember that your y values are your sines, x values are your cosines. So at 60 degrees, my cosine value is 1/2. At 60 degrees, my sine value is square root of 3 over 2. These are the values that we're popping in on that chart because it makes figuring out the rest of our angles really easy. Okay? Last special triangle we have is a 45-45 triangle. 45 degrees is the equivalent of pi over 4. Drop your, I guess I should be putting right angles in for all of these technically. I'm going to drop that vertical line down. Again, our radius is 1. We have a, we know with 45, 45, 90 triangles that our sides are square root of 2. So if I were to find the cosine, I would have square root of 2 over 1. Actually, these are square root of 2 over 2. I'm so sorry. Square root of 2 over 2, square root of 2 over 2. There we go. So if I were to find the cosine, again, I'm looking at my x value of that triangle, which would be square root of 2 over 2 over 1, which is just square root over 2. Square root of the sine would be square root of 2 over 2 over 1 also. My tangent for a 45-degree angle is square root of 2 over 2 over the square root of 2 over 2, which just gives us 1. So those are your basic 3 triangles. Now the only difference is what quadrant they may be laying in. So I could easily draw, let's say for example, I'm trying to find the reference angle for what would be in this, or sorry, I have 45 as a reference angle, and I want to figure out what this would be over here. So I know 45, and I go halfway around the circle. Now that adds to 180, so I am at 225. So I still know what my lengths are going to be. It's going to be square root of 2 over 2 and square root of 2 over 2. The difference is now I am on the left side of the sine axis or the y-axis, so my cosine value is going to be negative. These are all my negative values. And because I'm below the x-axis or the cosine axis, my x value is, or sorry, my y value, sine value is also going to be negative. So now when I'm finding that sine and cosine, my sine is going to be negative square root of 2 over 2. My cosine is going to be square root of negative 2 over 2. But my tangent is still going to be positive because a negative divided by a negative is still positive. And it's still going to be positive 1. These are the values that we're filling into that chart. So let's go down and do some practice on finding exact examples, and let's pop in some of our, we know our reference angles are going to be 30, 45, and 60. So 90 plus, so 30 back would be 150, 135, and 120. And let's go put our pi's in. Why not? Pi over 6, pi over 4, pi over 3. And this would be 5 pi over 6, 3 pi over 4, and that would be 2 pi over 3. Okay? When you have your unit circle, you'll be able to fill this in really easily. So let's do cosine of 120. So its reference angle, right, 120 is right here. So its reference angle is 60. Okay? So at 60, so I've got there. So my cosine at that point for my reference angle is 1/2. The difference is when I come down over here, now my cosine is going to be negative of that, negative 1/2. Okay? Sine of 210. So 210, I'm coming all the way around here. So right there I'm at 210. And I'm looking for sine, which is this distance here. So it's going to be negative, and I'm going down 1/2. Because in that triangle I know that my sine is 1/2, my cosine is square root of 3, or negative square root of 3 over 2. Oh, wrote that in the wrong spot, sorry. So remember, cosine values are just your x values, and sine values are your y values. Okay? That's another easier way for you to think of that. Cosine and sine. Okay, so tangent, well, tangent's kind of an interesting thing. So let's go all the way to 315. So I know that I'm at 90, 180, 270. 315 is going to be right here. So my reference triangle for that would be back over here at my 45, 45 triangle. Okay, so now the only thing I need to know, if I drop that down, my cosine is going to be positive, but my sine is going to be negative. So I'm looking, and it's going to be square root of 2 over 2, square root of 2 over 2. So the only difference now is what my resulting sine is going to be. So I have opposite over adjacent. I know they're both square root of 2 over 2, which is just going to give me 1. But negative divided by a positive would give us negative 1. Okay, so for secant, I know that's the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is going to be hypotenuse over adjacent. So let's go to 180, right? And my hypotenuse, I don't have a hypotenuse, right? So my cosine is at negative 1. So if my cosine's at negative 1, I just need to take the reciprocal of that to find my secant. So my secant is also at negative 1. Okay, good. Now let's look at things in radians and see if that makes any sense to us. Let's go ahead and label our reference angles. So pi over 6, pi over 4, pi over 3. And let's look at sine 5 pi over 4. So I know I'm working with this. So here's 1 pi, or sorry, 1/4, 2/4, 3/4, 4/4, 5/4 is going to be right about here. 5 pi over 4. And that should make sense to you because 5/4 is in between 1 pi and 2 pi. 8 pi over 4 would be 2 pi. Okay, so we're going to look right here. So I know in my 45, 45 triangle that I've got square root of 2 over 2. So my sine, I want you to look at whether it's positive or negative for each first. Okay, so anything down in this third quadrant, both sine and cosine are going to be negative. So that is going to be negative square root of 2 over 2, because that's the height of that triangle right there. Cotangent of 4. So tangent is opposite over adjacent, which means that cotangent is adjacent over opposite. So let's find pi over 4. Well, that's right there. And I have square root of 2 over 2 and square root of 2 over 2. So now the only difference is I'm going adjacent over opposite, but I still get 1 as my answer. Square root of 2 over 2 divided by square root of 2 over 2 is just 1. Okay, negative 2/3. So let's count in thirds. Those are all my 60 degrees. So here's 60, 120. At 120. Right there. So 60 degrees is my reference angle. And I'm looking for cosine, which means the distance that it's taking me right here, which would be 1/2, but it's on the negative side, so that's going to give me negative 1/2. All right, and last one, secant. Well, secant is the inverse of cosine, so it would be the hypotenuse over the adjacent. And if we're looking at 3/2, here I've got 1, 2, 3/2, or it's the inverse of cosine. Sorry, not the inverse, the reciprocal of cosine. Well, my cosine at 3 pi over 2, which is really 270 degrees, my cosine value, my x value is 0, because this point is 0, negative 1. So that means I have to go 1 over 0. Oops, can't do that. What do we call that when we're trying to divide by 0? We call that undefined. Okay, so we are just starting what is going to be the chart that we fill in from the unit circle. So we are going to find all 6 trig functions for 30 degrees. Okay, so in radians, that would be pi over 6. 6 times 30 is 180. And if I'm finding, here's my 30 degrees. Okay, and I know that this is 1, this is 1/2, this is square root of 3 over 2. So my sine value is just, remember that this is sine is the same thing as your y value, cosine is the same thing as your x value. So sine of 30 degrees would be 1/2. My cosine is square root of 3 over 2. And my tangent would be opposite over adjacent. So I want you to think about that. You would have 1/2 over square root of 3 over 2. So when I flip that and multiply, my 2's are actually going to cancel out. So in theory, I get 1 over square root of 3. But remember that I can't leave an irrational number in the denominator. So we're going to rationalize it. Maybe we get square root of 3 over 3. So now you've got where you're starting with that. Now you just simply need to take each one of these and flip it back over. So the reciprocal of 1/2 is 2, so our cosecant is 2. The reciprocal of square root of 3 over 2 is 2 over square root of 3, but I can't leave it like that, so I need to rationalize that denominator, and I would get 2 square roots of 3 over 3. And then my cotangent would be my tangent flipped over, which is 3 over square root of 3, but again, I can't leave that like that. So I would get 3 square roots of 3 over 3, which cancel out the 3's, and then you would get square root of 3. So my negative degree, if I take 30 from 360, I get negative 330. So that means is if I go in a clockwise direction, how many degrees do I have to go until I land at 30 degrees? Okay. In radians, all the way around is 12/6 pi, and I'm going all the way around except for 1. So that's going to put me at negative 11 pi over 6. Okay, let's work on the next one. So they gave us radians of pi over 2. So let's see if you can figure out quickly where that is. And we know that that's at 90 degrees. So I'm looking at this point right here, and then coordinates for that point are 0, 1. So your sine value is the y value. Your cosine value is the x value. And then sine over cosine gives you tangent. Well, the problem is you have 1 over 0, 1 divided by 0, which you cannot have, so that is undefined. We cannot find the tangent at 90 degrees. Cosecant is the inverse of these. So 1, this would be 1 over 0, which again we can't have. So the secant at 90 is going to be undefined. And then the cotangent is going to be cosine over sine, which is 0 over 1, which would be 0. You can't have a cotangent. Degrees, I'm just going to subtract 360, and I get negative 270. And radians, I'm going to subtract 4 pi over 2, and that would give me negative 3 pi over 2. Okay. Okay, lastly, let's test this and see where we're at. So I want you to tell me where you would have a sine of 1/2, meaning the height is 1/2, positive 1/2. So that would be at those 2 points. It should be 30, and then 180 minus 30 is 150. So this is really dealing with whether your lengths of those triangles that you've popped in are positive or negative. The cosine, where would your cosine be 1/2? Well, that's anything in this realm right here. So that distance here is 1/2 because it's half the hypotenuse, which is our radius. It's right here. And our radius is 1. So that would be at 60 degrees and at, so this would be 360 minus 60, which would be 300 degrees. Okay? And you can put these all in degree measures. That's just fine. Okay, tangent of negative 1. So tangent is when I've got sine over cosine, right? Opposite over adjacent. So I need to figure out where my height is negative 1. Sorry, that's not true. Where my sine and my cosine are the same, giving me negative 1, but where one of them is positive and one of them is negative. So if you think about your sines within these quadrants, this is negative cosine, positive sine. This is negative for both sides. And this is positive cosine, negative sine. Okay, so those are my two options where my tangent is going to be negative. So I'm going to have a negative divided by a positive, positive divided by a negative, negative divided by a positive. So the reference angle for that would be 45. And so in this quadrant, my 45-degree angle is at 135. And in quadrant 4, it would be at 315. Okay, and then square root of 3 over 2. Where would that's the tall side of my triangle at either the 30 degrees or the 60 degrees. So right here, my sine is going to be positive in quadrants 1 and 2. So at that point, it's 60 degrees, and then add another 60 would be 120 degrees. Okay, last two, and we're done. Cosine, where's my cosine 0? Which means it's right on the y-axis. So at 90, and then again at 270. Then I need to see where my cotangent is undefined, which means cotangent is x over y. So I need to find where y equals 0. So that means I'm sitting on the x-axis because I am not going up or down. So my cotangent is undefined at 0 degrees and 180 degrees. I know it seems overwhelming. I know it seems kind of confusing right now, but trust me, we'll get easy. See you soon.